Imagine discovering a world-shifting chemical element, not in a sterile laboratory or deep inside a volcano, but in human urine. In 1669, a German alchemist named Hennig Brand wasn't looking for a new element. He was obsessively trying to manufacture pure gold out of ordinary materials. His process involved collecting thousands of liters of urine, repeatedly distilling it, and boiling it down over massive fires. The experiment failed to produce gold. Instead, it left behind a strange, pale substance at the bottom of his glass vessels. While chasing a shiny metal that holds only symbolic value, Brand accidentally isolated a substance that is a physical requirement for every living cell. That source material he collected in such massive quantities was in fact human urine, and the residue he extracted from it defied all 17th century understanding of nature. It emitted a ghostly green light in the pitch dark, without requiring any flame. Brand had unknowingly isolated white phosphorus, element 15. This marked the first time a new element was identified using repeatable scientific methods. The pursuit of magical transmutation failed, but Brand's success in isolating a specific component of matter provided a template for identifying the rest of the periodic table. To see why element 15 is so vital, we have to look past the alchemist's flask and zoom deep into the human bloodstream, pushing right down into the nucleus of a single dividing cell. Here, phosphorus acts as the structural backbone holding together the DNA helix in every living organism on Earth. It also forms the core of a molecule called ATP, or adenosine triphosphate. This diagram shows ATP acting as cellular currency. By breaking off a single phosphate bond, the cell releases the burst of energy needed to function. Every macroscopic action relies on this microscopic transaction. Without ATP, your brain cannot fire signals and your muscles cannot move. If biological life is an engine, phosphorus is the irreplaceable fuel keeping it running. That biological role scales all the way up to our planetary food supply. For centuries, agriculture faced a biological limit. As crops grow, they pull phosphorus out of the ground. Once the soil is depleted of that nutrient, growth stops. Overcoming this required a massive industrial effort. By mining phosphate-rich minerals, humans built sprawling complexes like this to mass-produce synthetic fertilizers, injecting this element back into exhausted farmland. Returning phosphorus to the soil multiplied crop yields globally, allowing us to feed billions of people. Every meal eaten today is directly tied to this chemical intervention. Phosphorus is the primary currency sustaining human food production. But element 15 has a volatile side.
The exact same white phosphorus that emits a gentle glow in the dark will violently ignite and burn at intense temperatures the very moment it is exposed to oxygen in the air. Its stability comes down to geometry. This diagram shows volatile white phosphorus arranged in a tense tetrahedral structure. A simple shift into the long, chain-like structure of red phosphorus makes the element stable and safe to handle. Militaries exploited the violent reaction of the white variant, using its unquenchable flame for smokescreens and incendiary weapons that caused catastrophic injuries. The chemical property that sustains living cells is the same one used to engineer destruction. Science is neutral. Only humanity's choices dictate the outcome. Unlike gold, which sits static in a vault, phosphorus is a resource we must consume every single day to survive, and that daily consumption faces a harsh geological reality. The global supply of raw phosphate rock is finite and non-renewable on human timescales. Our known, accessible deposits are strictly limited. We are operating against a ticking clock to maintain the crop yields that keep the global population alive. Humanity is rapidly spending down an irreplaceable natural resource that our global food supply depends upon. Scientists and agricultural industries are now prioritizing sustainable use and new recycling methods to capture and reuse phosphorus before it washes away. It is a massive responsibility for an element that began as an alchemist's accidental discovery, only to become the industrial requirement for feeding billions. It proves that the smallest, most unexpected chemical building blocks quietly support the entire world around us. In our next episode of Atomic 118, we will examine how another unexpected element transformed human history through a different mechanism. We must carefully steward these elemental resources. They are the only assets that guarantee our future existence.